All right, 58 is following right up on that triangle inequality theorem we just talked about, the triangle inequality theorem, which matches up the sides and the angles. It doesn't give an exact number for the sides, but it tells us the relationship between the sides. Here we have to do it in both triangles, however, because we've got two triangles. So first I'm going to find out the missing angles. I've got 65 and 80. If I add those two numbers together, I get 145, which leaves 35 degrees left over for this little angle on the outside. So I'm going to go ahead and actually number right now in this triangle. That would make this side small, this side medium, and this side large in that triangle on the right. Okay, let me go ahead and do the same thing for the other triangle. This is 50 and 70, and 50 plus 70 is 120, and 120 minus 180 is 60 degrees. So let me go ahead and label this. This is small, medium, and large. Okay, so now that I've labeled the two triangles, what I need to do is figure out which one's the smallest overall. And let's look over here. In this triangle on the right, B, which is the smallest angle, is also the longest side over here on the triangle on the left. We can even affix numbers to them if you want to. We can go ahead and just say approximate numbers. This small, medium, and large. Let's say this is 5, 6, and 7. Okay, those are just random numbers. Well, over here, B is still 5, but that's now the biggest number. So M has to be smaller than that, like maybe 4, and C has to be smaller than 4, which is maybe something like 3. So we want to go from least to greatest. Here with those numbers, I think it's easy to see that C is going to be the smallest overall, followed by A, which I had assigned that 4 to, followed by B. So here's where we pick up the second triangle. B is smaller than E, which is smaller than D.